Hello, so I'm Uttam Gupta. I'll be explaining you Navier-Stokes equation as a part of my PD assignment. So let's begin. So as you can see on the screen, Navier-Stokes equation, basically we'll be talking about fluid mechanics, is a partial differential equation that describes the flow of incompressible fluids. The equation is generalization of the equation devised by Swiss mathematician Leonardo Euler in the 18th century. So to describe the flow of incompressible and frictionless fluids. So in 1821, a French engineer, Louis Navier, introduced an element of viscosity for the more realistic and vastly more difficult problems for viscous fluids. Throughout the middle of 19th century, British physicist and mathematician Sir George Stokes improved on his work, and though complete solutions were obtained only for the case of simple two-dimension flows, the complex vortices and turbulence that occur in the three-dimensional fluids flow as velocities increase have proven intractable to any but approximate numerical analysis method. So basically the Navier-Stokes equation, as you can see on the screen, is rho dv by dt is equal minus del p plus rho g bar plus mu of del square v bar. Sorry. So let me tell you basically I'll be explaining this equation in two parts. First, I'll be explaining the equation, then I'll go to the derivation. So explaining the parts of this equation, explaining the variables in this equation. So rho dv by dt is the force exerted on each particle, each fluid particle. So when a fluid is flowing, so rho dv by dt is the force exerted on each fluid particles. Mu is the dynamic viscosity, v bar is the velocity vector, g is the acceleration vector due to gravity that we already know, and rho is the density of the fluid. So detailed physics represented by this equation, I have already submitted the copy of this assignment. So detailed physics represented in this equation. So sorry, the equation shows that the applied force is composed of the following components. When a fluid is flowing, so in that fluid, each particle will experience some force. So the equation shows the applied force is composed of the following component. So minus del P is the pressure component, also known as volumetric stress tensor, which presents motion due to the normal stress. Rho G bar is the force term acting on each fluid particle due to gravity. Mu del square V bar is the stress term, also known as stress deviator tensor, which causes motion due to horizontal friction. And shear stress. Shear stress causes sorry. Shear stress causes turbulence and viscous flow turbulence in the result of shear stress. So now moving on to the second part of the derivation. I have already explained you the terminology of this derivation. Now I'll tell you shear stress causes turbulence and viscous force if you drag your hand through a liquid. Like this is a liquid. I have added some graphs also. I've added some figures also that will help you to understand better. So if you drag your hand through a liquid, you will notice moving liquid also causes nearby liquid to start moving in. Let's say there's a container or there's any flow of liquid. If you move your hand through the liquid, then you'll notice the particles that are touching your hand will start moving. Also, the particles of liquid or fluid near to those particles which your hand is not touching will also start moving in the same direction. Turbulence is basically a result of shear stress. Example, force term acting on every single fluid particle due to gravity. Sorry. Force term acting on every single fluid particle due to gravity. So again, some terminologies I have used. Mu is the dynamic viscosity, V is the velocity vector, G is the acceleration due to gravity, E is the density of fluid. I have already explained. So let this be the example I was talking about. Consider a fluid flowing from left to right, from this corner to this corner. Let's say a fluid is flowing We take a differential fluid element. Uh, let's say this is the differential fluid element. Consider the element as a material element instead of a control volume. So this is a material element, and apply now, basically just simply apply Newton's second law. F sigma of F bar is equals to m into A bar. This simple Newton's second law. So since A vector t is equals to dv by dt, so m into dv by dt is equals to sigma f, that is equation 1. So we express total forces as sum of body forces and surface forces. So total force is equals to force on a body plus forces on surface. So we express total forces as sum of body forces and surface forces. So sigma f is equals to sigma f body plus sigma f surface. So again, putting the value, f is equals to m into dv by dt is equals to sigma of f body plus sigma of f surface. Body force is gravitational force majorly. So I have explained what these forces are. Body force is gravitational force and electromagnetic force, centrifugal force, etc. Sorry. Surface forces are pressure force, viscous force. Yeah. So the major forces are due to gravity, differences in pressure, and due to viscosity of fluids. Let us consider. Wait, I'll use the size. Huh. So consider this element which we have introduced here. So this is a material element. So this is the x-axis, y-axis, and z-axis. Consider the x component of equation 2. Now as m is equals to e into dx dy into dz, so v is a vector, that is u, v and w. So e into dx dy dz into du by dt is equals to sigma of forces of x into body plus sigma of surface. Sorry, plus sigma of forces on x-axis, forces on surface acting on x-axis. So e, it is actually rho. So rho of dx dy dz is equals to d mu by dt. So here rho into dx dy dz d mu by dt is equals to rho into g into in x direction into dx dy. So on solving the equation, we can say and solving and by dividing both sides by the volume of differential element, and doing this we get rho into gx plus sigma into sx x plus dx minus sigma into in x direction divided by dx, and adding all three will give you rho into ax. A is acceleration. On solving the equation further, we get rho into xx is equals to minus of beta plus 2 mu into d of mu by dx. Sorry. On substituting the values of all these values in equation 5, all the values we've calculated, on substituting these values in equation 5, we get rho into gx minus d rho by dx plus mu of rho square mu in x, for like double derivative of mu with respect to x, double derivative second derivative with respect to y plus second derivative with respect to x plus mu of d by dx of d mu plus dw plus dw by dz is equals to rho into ax. Also, Navier-Stokes equation satisfies the conservation of mass, momentum, and energy. Mass conservation is unique. Is implicitly through the continuity equation. So, finally, on applying the continuity equation, and conservation of momentum requires momentum is equals to mass plus pressure plus body force, the force acting on body plus viscosity. So, writing the mathematical term and applying the conservation of energy applying the conservation of energy, we easily obtain ds by dt is equals to minus mu plus del s minus mu into del s plus q by t. S is entropy per unit mass and sorry, continuity equation. Wait a sec. Hmm. Continuity equation is as you can see du by dx plus du by dy plus dw by dz equals 0 in case of incompressible fluids. Now merging the equations, we get rho into du by dt plus mu du by dt plus v du by dy plus w du by dz. That equals rho into geo into x action minus dp by dx plus mu into second derivative of mu with respect to x, second derivative of mu with respect to y plus second derivative of mu with respect to z. Yeah. Similarly, for y and z components, we can write the same equation for y and z components. Now, the vector form of these equations will give rho into dv by dt is equals to minus of delta p plus rho into g bar plus mu into del square v bar. So this is basically the Navier-Stokes equation that we have proved. This is the same thing. Yeah. Now coming to the open form and solver code syntax. So this is a location where you can access the icoform.c, and hope that was a very important session, and hope you understand. So if you have any questions, just write in the comments below. Comment below and I'll help you out. Thank you.